In this video, I'll show you how to solve the ALEKS problem called Recognizing Exceptions to the Octet Rule. So this problem is going to give us a Lewis structure, and we have to decide whether or not the Lewis structure is correct, and if it's not correct, we have to decide exactly what's wrong with it. And for each one of these, I think that the easiest thing to do is start by checking the number of valence electrons. So that's what I'm going to begin with. Remember, the number of valence electrons is based on the number of valence electrons in each atom, and that's based on the atom's location on the periodic table. So for AlCl3, we have aluminum, which is in the third column. So this has 3 valence electrons. And then we have 3 chlorines. Chlorines are right here in the 7th column, so they each have 7 valence electrons. So we have 3 plus 21, that's a total of 24 electrons. And so if this structure is correct, we should see a total number of 24 electrons in the drawing. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That is wrong, the wrong number of electrons. We only are allowed to have 24 valence electrons. So this one, we've got this one figured out. The total number of electrons should be 24 instead of 26. Let's see if we can apply that same thing to our second problem. Sulfur is right here in column number 6. So there's 6 valence electrons for the sulfur. And then for the fluorine, we have 3 fluorines. Each fluorine has a total of 7 valence electrons, which is 21. And then don't forget that negative charge. That negative charge means we need to add 1 electron. If it's a positive charge, we subtract 1 electron. 6 plus 21 plus 1 is a total of 28 electrons. That's how many we should see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. That is the correct number of electrons. That means we cannot choose this, no, the number of valence electrons is wrong. Maybe the structure is right, but it still might be wrong. For our last example, OF2, oxygen is in column number 6. So it has 6 valence electrons. We have 2 fluorines. We had the fluorine atoms in our last example. So fluorines each have 7. That's a total of 20 valence electrons. And in this structure, we see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So again, it does have the correct number of valence electrons. Doesn't necessarily mean it's correct. So now what we have to do is decide whether atoms have the right number or the wrong number of electrons around them. And in general, what we're going to be looking for is the octet rule, which is going to tell us that we want to have 8 electrons around each atom, or 2 electrons if it's a hydrogen. Now there are some atoms that are able to violate the octet rule, but all atoms can follow the octet rule. So we're going to start by just looking for 8, and if any atom has a number other than 8, then we're going to analyze it on its own. I'm going to erase this highlighting that I've done here. We'll start with the fluorine. This fluorine atom has 2, 4, 6, 8, so that fluorine atom is good. Let's take a look at our next fluorine atom. It has 2, 4, 6, 8, and our last fluorine atom, 2, 4, 6, 8. So all of the fluorines have 8. We know for sure that that's good. Now let's take a look at the sulfur. Sulfur has 2, 4, 6, 8, 10. So that may or may not be okay. If we have 10 electrons on an atom, like in this case we have it on sulfur, there's a couple of things that we can do to decide whether or not that's an okay thing for the sulfur to have. Number one, we can take a look at where the atom is located on the periodic table. Anything that is further down on the periodic table, so anything that is in the 3rd row, sulfur's row or below, all of these atoms are large atoms, so they are capable of holding extra electrons on them. So that's one thing that we can evaluate. Just the size of sulfur kind of gives us an idea that this is going to be okay. But a more foolproof way, a more accurate way of determining whether or not 10 electrons on a sulfur is all right is by counting up the formal charge for the atom, sulfur in this case. Formal charge is going to be calculated by taking the number of valence electrons on the atom, subtracting the number of bonds that are around that atom, and then subtracting the number of non-bonding electrons around that atom. So for sulfur, we decided that it had 6 valence electrons, and this particular sulfur has 2, 4, 6 bonds, And also this particular sulfur has, excuse me, not 6 bonds. It has 3 bonds, not 6 bonds. 3 bonds, and it has a total of 1, 2, 3, 4 non-bonding electrons, which gives it a formal charge of -1. If we have formal charges of 0 or a +1 or a -1, those are good formal charges. They're perfectly acceptable formal charges. So the combination of having a good formal charge and having a large atom like sulfur that's able to hold extra electrons, those two things together will tell us that yes, this is a reasonable structure. It's okay. Let's practice that again down here on this molecule. So it has the correct number of valence electrons, but does it have a reasonable structure in terms of the octet rule? That's what we're going to analyze next. Start with the fluorine. First thing that we're going to do is just look for atoms that are not following the octet. For fluorine, we have 2, 4, 6, 8, so that fluorine is fine. Fluorine on the right-hand side, 2, 4, 6, 8, that fluorine is also fine. Now let's analyze the oxygen, 2, 4, 6, 8, 10, 12. Okay, so we have 12 electrons on an oxygen, and we have to decide whether or not that's going to be okay. So first of all, oxygen is up here on the periodic table. Remember, I told you if our atoms are large, it's okay to have extra electrons on them. Oxygen is not considered a large atom. Anything that's in the first column or the second column, those atoms are considered to be relatively small and not capable of having more than 8 electrons around them. So this right away is giving me a sign that this is probably not going to be an okay situation for oxygen just because of its size. We can confirm that by calculating the formal charge, because that's always going to be, like a double check. The valence electrons for oxygen atom is 6. This oxygen atom has 1, 2, 3, 4 bonds. And in terms of non-bonding electrons, 1, 2, 3, 4 non-bonding electrons. So this is a formal charge of a -2. And a formal charge of -2 is too high. Like, that is more formal charge than what we're accustomed to seeing. So I'm going to mark no, this is not okay. Combination of oxygen is too small to have extra electrons and the formal charge is too high. Those are two bad things. The problem atom is oxygen in this molecule.